Hey guys, so wish me luck. First video for Integrated 2. We're going to do Section 821. Section 811 is constructions. You guys probably remember those at the end of Integrated 1. You would get compasses out and sort of draw arcs and do perpendicular bisectors and that kind of a thing. I'm bummed out. I really like doing that stuff, but I just feel like it's probably a good section to sort of skip over based on where we're at in the year with the coronavirus thing and all that good stuff. So I might get around to making a video for it, and then I guess if you guys have a compass, you should be able to download the PDFs or whatever if you want and print them out. But it just feels like it's probably better to start with Section 821, so that's what we're going to do. We're looking at angle measures. This chapter is it's kind of a cool chapter, I think. It is going to involve some trig by the end, so I'll probably have to make a video for reviewing trig, but we're not that far yet, so sort of see how it goes. So anyways, in chapter 1, you prove that the sum of the measures of the interior angles of a triangle is always 180 degrees, the triangle angle sum theorem. Hopefully you guys recall that. What about the sum of the interior angle measures for other polygons, such as hexagons or decagons? What about their exterior angles? Do you think it matters whether the polygon is regular, that is equilateral, equiangular? I mean, it doesn't matter as far as how many angles there are, but it does matter as far as like if it's regular, meaning that they're the same, that all the angles will be the same. Like this isn't a regular pentagon. A regular pentagon looks more like, you know, the star, where all the sides are the same and all the angles are the same. So this isn't a regular pentagon. It's going to have the same sum of angles if you add them all together, but clearly this angle is not the same as this angle. So anyways, that's kind of what we're looking at in this chapter. It's a pretty cool chapter. You can kind of see how triangles work in other shapes like we talked about multiple times, and this is just going to be another example of that. So copy the pentagram at the right on your paper. With your team, determine the sum of the angle measures of the interior angles of the pentagon using any method. So I don't know, you know, maybe pause the video and see if you can figure it out, but there's a couple different ways that we can do it. But one of the coolest ways is if you start from one point, it doesn't matter which one. We already have this line drawn and we already have this line drawn, so there's only two other points to draw to. You'll notice that we end up with 1, 2, 3 triangles. So it literally works like this: 180 times the 3 triangles. We know there's 180 degrees in this triangle, we know there's 180 in this one, and we know there's 180 in this one. So we'll multiply those together, and we know that there's 540 degrees in this shape. It is literally that simple. So I think kind of cool. All right, as we move along, it says the sum of the interior angles of a polygon. So in the previous problem, you found the sum of the angle measures of a pentagon, but what about other polygons? It asks you to get this resource page. You should be able to click a link in the ebook if you have one. If not, I sent you the link to get the ebook, so you should have one. If I remember, I'll put a PDF in the file. I probably won't, so you know, I guess if you really need one and you have an actual textbook and you need this resource page, reach out to me to remind me if I do forget. Anyway, this software doesn't always work the way I want it to, although I'm much happier with it than the other software that I was using. So hopefully we'll be good on this. So I am going to open this resource page, and we're just going to sort of answer our way through it. I think that's a pretty good look right there. I want to sort of be able to write on it, move it along. So anyways, we know that this has 180 degrees, right? I mean, pretty simple. Oh, they actually filled it in for us. Well, this should have 180 times 2. So if there's 4 sides, it should have 360. This should have, like we talked about already, 3 triangles or 540 degrees. So we go down here and we're going to put that there's 540 degrees. And again, what I'm saying is if you add up the sum of all the angles, that's how many degrees it's going to be. Here we have 1, 2, 3, 4 triangles. Again, sometimes I get students that are kind of just sort of drawing triangles wherever, and they're like, I have a million triangles. That's not how it works. Be real organized the way you do this, and you know, start at one point and go to the others. It doesn't matter which point you go from. If I start here, fine. I'll go this way, and you'll see I still have 4 triangles. So 180 times 4 is going to be 720 degrees. Again, that says 540. It looks like garbage, so I'll try and clean that up a little bit. My handwriting has not improved. If we go to 7, 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. So that's going to be 900 degrees. And if I go to 8, it's 1, 2, 3, 4, 5, 6. 6 times 180, I think I could probably use a little help. I think it's going to be 1,080 degrees. So now it asks if there's what we should do if there's 100, and man, I can't. You know, I'm not. That's 100 sides. I have no idea. So we need to sort of notice a trend of what's going on here. You'll notice it keeps adding by 1, but what I really want you to focus on is if we go back up here and look. Hey, look, when there was 3 sides, there was 1 triangle. So again, I'm gonna kind of make a chart. There was 3 sides and there was 1 triangle. And when there was 4 sides, there was 2 triangles. And when there was 5 sides, there was 3 triangles. And when there was 6 sides, there was 4 triangles. And when there was 7 sides, there was 5 triangles. When there was 8 sides, there was 6 triangles. So hopefully we've recognized the pattern now that if there's 100 sides, there must be 98 triangles, right? We're just subtracting 2 each way. So I just need to know what 98 times 180 is. And I got to be honest with you, I shouldn't have put that there. I should have put that there. Anyways, I don't know the answer to that, so I'm going to grab a calculator. 180 times 98 is going to equal 17,640. So I can go down here, and I can fill in 17,640. I'm going to not have a lot of room to do this. I actually looked way better than I would have imagined. And again, now we sort of run across this thing. Well, what if we had n sides? Like, they don't tell us. They're just saying, like, I don't know. What if I just gave you n? Well, it seems like what I would do is I would say, well, I'll take however many there is and I'll subtract 2 from it, right? 3 minus 2 is 1, and then I multiplied it by 180. And 4 minus 2 is 2, and I multiplied it by 180. So I guess what I'm going to do is just say n minus 2 times 180. And no matter how many sides there are, I'm just going to multiply that by 180. So I really like this triangle trick right here a lot. But the problem is if you give me a 100-sided shape, I'm not going to be able to figure out there's 98 triangles. So this formula is going to be important, right? Take the number of sides, subtract 2 from it. That'll give you how many triangles there are, and multiply those triangles by 180. Essentially doing the same thing here. I hope that makes sense why this formula is important and not just this trick, although this trick is really handy. It's certainly easier to remember and a lot more visual than this formula is. All right, so that did not mean to do that one. I do not want to screw up this video and have to start all over. This is the one I want. Okay, so let's go back to the lesson and keep working. So we have, I say, by the way, and so a lot in these videos. I apologize. I probably will never be a speech teacher, I suspect. There we go again. So we answered these questions, and we are good to go to 823. I'm so conscious right now of every time I say I'm killing myself. This is driving me nuts. So 823, interior angles of a regular polygon. Now, again, we said a regular polygon means all the sides and all the angles are the exact same. So Fern is helping a friend with their math homework, and they get stuck determining the value of x in the diagram shown at right. Fern says, I know how to calculate the sum of the angles of a hexagon, but how am I supposed to determine the individual angle measures? Well, this one is easy because all the angles are the same. You can just divide, which makes a lot of sense, right? I'm going to figure out how many angles are in the whole shape, and then I'm going to divide that by 1, 2, 3, 4, 5, 6, 6 angles. And that seems like it would be a fabulous strategy to employ, so we will. So we just answered what we meant there. We know that there's 6 sides. That means there's 4 triangles, right? And times 2. So we know that the diagram has 720 degrees. So use your findings, then write the equation for x. So we're gonna say 6 minus 2 times 180 is our equation, and we're gonna end up with 720 degrees. So that is how many degrees are going to be in the whole thing. Now we know we need to solve for x. Well, there's 6 x's there, right? So I'm just going to divide that by 6, and each x is going to be worth 120 degrees. I hope you guys followed that. If you didn't, I think one of the nice things about a video is you can definitely rewind it. Rewind it. It's not a tape. I guess you can go backwards, whatever it's called. Anyway, skip back and get it. Fern says, I get it. Hey, that could work for other regular polygons. Determine the measure of each interior angle of a regular octagon. Explain how you find your answer. Well, again, I'm going to say, all right, well, there's 8 sides. I'm going to subtract 2 and multiply that by 180. So 6 times 180 is going to give me 1,080 degrees for the whole shape. Right? This whole thing is 1,080 degrees. But I have 8 angles that I need to disperse this to. So I'll divide this by 8, and I will get, by the way, I have a calculator handy, feel free to use one, 135 degrees. So each of these is 135 degrees. And if you don't believe me, you can multiply 135 by 8, and you should end up back at 1,080. And again, the fact that this is a regular polygon is a big deal. If it's regular, you can assume all the angles on all the sides are the same. If it just says it's a polygon and it doesn't say regular, none of what we talked about is necessarily true. Well, that's not true, actually. We can use that to figure out the total degrees in the shape, just not what each particular angle is from there. All right, so what about the interior angles of regular polygons? What are the measures of the interior angles of a regular nonagon? I don't even know what a nonagon is. I'm pretty sure it's 9-sided. Is it worth doing a Google? Let's just, I feel like it's 9 sides, but we should probably confirm that. Let's emails. Nonagon. Is a 9-sided shape. All right. So I keep doing that, and I don't want to. So if I have a 9-sided shape, we're gonna say 9 minus 2 times 180 is gonna be 7 times 180. Again with the calculator. We're going to get 1,260 degrees. I'm going to divide that by 9 sides. And I'm going to get 140 degrees. If we have 100 gone, I'm going to say 100 minus 2 times 180. I'm going to have 98 times 180 is 17,640. And I'm going to divide that by 100 angles. 100 angles, and I will get 176.4 degrees. I actually didn't even need a calculator on that one. Will the process you found work for any regular polygon? Yes. Write an expression that will calculate the measure of an interior angle, an n-gon. So again, we're going to say, well, n minus 2, right, times 180. We have to subtract 2 here to get the amount of triangles, but once we've done that, we're going to come back and divide by n. So that will evenly disperse it to each of the angles, if that makes sense. So hopefully we're doing okay with this so far. We will now go ahead and see if we can bring in the next section. It hasn't been working great. It's just going back to the original one. Yeah, I'm actually going to have to close this program, obviously, and then open it again. It's probably the biggest problem I have with this program. I really like it compared to what I was using. All right, so we are left off here. Last we were talking about this. So Jeremy asked, what are the exterior angles and what can we learn about them? By the way, I should include like a note sheet, and you might want to fill that out, like what the interior angles are, what the exterior angles are. Just have something readily accessible. That way you have something that you can just grab when we do this stuff and not have to flip back and forth. I'll probably talk about that later or upload it or make a short video about that or whatever, but for now I'm just doing this. So what are the exterior angles and what can we learn about them? Examine the regular hexagon shown at right. Angle A is an example of an exterior angle. That's an exterior angle because it is on the outside of the hexagon and formed by extending one of the hexagon sides. What can you conclude about the exterior angles of a regular polygon? Well, it sure looks like I have a supplementary relationship with the interior angle, right? So if I figure out what this is, let's say this was 100, well, I guess that would be 80. Or let's say this was 120, I guess that would be 60, because it certainly looks like I have that supplementary relationship, the fact that they add up to 180. So that's what I would say there. What is the value of A? Well, I mean, on this one, we have a hexagon, so we're going to say 6 minus 2 times 180 divided by 6. So we're going to get 4 times 180 is 360, 720. 720 divided by 6 is 120 degrees. So if this is 120 degrees, well, this must be 60 degrees because we have that supplementary relationship, right? 120 plus x equals 180, and so x has got to equal 60. What is the sum of the measures of the exterior angles? By the way we just did this is not the way we're going to want to do this. I'm going to show you a way better shortcut than figuring it out this way. So, well, this is 60, this must be 60, this must be 60, this must be 60, this must be 60, and this must be 60. So 60, 120, 180, 243, 360. Hey, they add up to 360 degrees. Why? I don't even know what to say to that. That's a great question. I don't know why. I guess because supplementary relationship. I don't know what the book's searching for as far as the why. What can you determine about the exterior angles of other polygons? Well, let's think of a square. If this is 90 degrees, this is 90, this is 90, this is 90, and this is 90. Hey, they add up to 360. What if we have a triangle? This is 60, so this is 120. This is 120. Oh wait, that should have gone like that, darn it. And this is 120. 120, 240, 360. I'm noticing a trend. It looks like they all add up to 360 degrees. So calculate the measure of one exterior angle. So here's what I'm going to do. 360 divided by 3 equals 120 degrees. That's going to be the exterior angle. A decagon. 360 divided by 10. 10 sides in a decagon. That means 36 degrees is the exterior angle. Octagon. 360 divided by 8. Again, back to the calculator. So 360 divided by 8. Ugh, jeez. Fat thumbs. 360 divided by 8. 45 degrees. I don't know how I didn't know that. Again, that is the exterior angle. Here, dodecagon, 360 divided by 12 is 30 degrees. That's the exterior angle. So the exterior angle is actually very easy to find. And now think about it. We know that there's a supplementary relationship. So I guess the interior angle here would be 60, right? Because 120 plus 60 equals 180. The interior angle here would be whatever 180 minus 36 is. So we're going to get 144 degrees is my interior angle. Here, my interior angle is going to be 135 because they add up to 180. Here, my interior angle is going to be 150 because that adds up to 180. So that's a way better shortcut than doing it the long way. So So just to kind of wrap this up, because I'm not sure everybody is really going to see exactly what it is that we're kind of talking about here, and I definitely want you guys to kind of see what it is that we're talking about. But what if I will go with a what are we doing here? Okay, I'm gonna go here, and I'm gonna go here, and I'm gonna go here, and I am going to go here, and I'm going to draw a big white box. Then I was kind of hoping that I would be able to draw like a yeah, I'm not getting the shapes that I wanted. I was hoping I would get like a pentagon or a hexagon or something like that, but I'm not. So it looks like I'm gonna have to hand draw this thing, so you know it is gonna look like crap. All right, so let's try and make it easy on me. Jeez. Okay, so again, as you can tell, I'm sort of giving up on any hope of sort of starting these videos over. Like, I just, like, it is what it is. Whatever happens is whatever happens. You know, this is really unfortunate because I'm actually not that displeased with that hexagon, but I wanted to leave myself a little bit more space because I want to do this thing twice using two different methods so that we can see which one is superior. So I feel like I should move that over here. I apologize for wasting your life. Although if you're watching this in 2020, I mean, I guess I was kind of thinking I may as well set these things aside for like future years. But if you're watching this video was made during the coronavirus outbreak, so you probably can't go outside anyway, so you may as well just sit here and watch this video for an extra 2 minutes. So if we want the interior and exterior angle, here's the long way to do it, which, I mean, it's fine. I just don't know that it just takes so long. First, we're going to figure out the interior angle. We're going to say, oh, look, this is 6 sides minus 2 times 180 divided by 6. So 4 times 180, 360, 720 divided by 6 is 120 degrees. So I know these interior angles are all 120 degrees, right? I don't need to draw them all, but they're all 120 degrees. Hopefully we all agree with that. So that's the interior angle. Now I'm going to go here and figure out the exterior angle. Well, the exterior angle is supplementary. So 120 plus 60 equals 180. So I've calculated my interior and my exterior. This isn't the way that I would do it, though. I think what I would do is use the exterior angle. Hey, look, there's 6 sides. I'm going to divide 360 by 6 and get 60 degrees. So I know that my exterior angle is 60 degrees. And I know I have the supplementary relationship, so I know my interior angle must be 120. This is the way I like doing it. I do not like doing it this way. I feel like that's way too much extra work. It's way too easy to screw up. This is so much cleaner to get that. The other point I want to make is this. We're going to talk about something called the central angle. And here's, I'm going to kind of clean this up a little bit. The central angle ends up being, actually I probably should leave at least one of those in there. The central angle is like if you cut this thing like a pie in the middle. Well, obviously it's 360 divided by 6 to get 60 degrees, right? I mean, each of these central angles is also 60 degrees. So over here, if we do it this way, it's the same formula, right? Once we do 360 divided by 6, it's not only the exterior angle, but it's also the central angle. So you may as well do this one problem and figure out 2 of them and then do this rather than going through all this and then end up using this formula anyways to get the central angle. I hope that makes sense. If it doesn't, please reach out. Again, I hope you guys are all doing well, and I will talk to you later.